So far, so good? Okay. Now, number 3. I now put this car in a vat of water. What's that force called? Anyone remember? Buoyancy. So how will my equation change? And I will always have mg pointing downwards. Yes. The force pushing will now be called. Do you notice where I'm drawing these forces from? Always the surface. Mg always starts at the middle. And these forces, for me, I know a lot of textbooks will write it any which way you want. I tend to write them exactly at the surface of where they start. If I have a friction, I'll start it at the surface. If I have a normal force, I'll start that at the surface too. Sigma Fy will be buoyant force acting upwards minus mg. Or Fb equals mg. What car is doing is providing a push force. So there's a box, and then there's another box. And the push force is what the car is applying. So let's call it P. So then it will be, let's call this one M1, and let's call this one M2. And the car is just providing the push force. Right? Equations of motions. Notice, how many masses are involved?
3.
Technically 3, but what is the car doing? Just pushing. So remember I didn't tell you what this push force was up here. What is applying this push? It doesn't matter what's applying the push. Do you see the difference? You will think that there are 3 masses in this problem, but the car is just there to apply the push force. So you do not have to write a separate force equation for the car. Make sense? Okay, so there are 2 masses that we have to deal with. So not only do we have to worry about sigma fx and sigma fy for one mass, but we have to write it twice. So for mass 1, what does your sigma fx equation look like? This is where Newton's third law will become very important. Just watch. So the car is applying the force on mass 1 only. So push is being applied to mass 1. But mass 1 is applying the force to mass 2. Correct? So that means it is experiencing F21 from mass 2. Just like when you stand on the scale, what the scale is reading is how much it has to push you. Okay? And then sigma Fy will just be N minus M1G. Now, what should it be for sigma Fx for mass 2? Should there be a push force in there? And the answer is no, because the car is not pushing mass 2. It is experiencing the force from mass 1 only. And what is it experiencing? What direction is that force? That way. That's what the cool part about doing Newton's laws is. So once you can write these laws, it makes sense. All 3 of them have to work together in order to come up with a problem. And again, the same thing will happen if it's accelerating, if it's not accelerating, if it's moving in a circle. Put them, where do you always put sigma fx, ma, where do you always put ma or 0? Always in the left side. You don't touch the right side because that's just telling you the sum of the forces, right? Yeah, exactly.